In this video lesson, we'll be solving logarithmic equations using properties of logs. In particular, we'll be using the product rule of logarithms to be able to solve an equation. Logarithms, unfortunately, are not like other functions. When you add and subtract them, you can't add and subtract the logarithm of a certain base b. So instead, we have a product rule that allows us to take the sum of two logarithms of the same base and combine them, or what we call condense them, to its product. From there, we will be able to solve and check our solutions. Let's take a look at an example. In example 1, we're going to take this sum and we're going to use the product rule and rewrite it as a logarithm of base 3 of 2 times x equal to the logarithm base 3 of 6. Because they share the same logarithm of the same base, what we know is we can take those expressions and set them equal. So we will set them equal and solve. So 2x is equal to 6, divide by 2, x is equal to 3. Now we want to check our solution, okay? By doing that, we're going to take the value for x and we're going to replace it into each logarithm where it has a variable for x. As long as this variable, when it's being replaced by its number, as long as that logarithm is not a negative logarithm, then it is a solution. So for example, a logarithm base 3 of 3 plus the logarithm base 3 of 2 is equal to the logarithm base 3 of 6. Since this value is non-negative, then we know that it will be a solution. Let's take a look at another example. In this particular case, using the product rule, we will get the log base 4 of x times x plus 3 is equal to the log base 4 of 10. Again, because we are equal to the same logarithm of the same base, we can set the expressions equal. So x times x plus 3 is equal to 10. Using our distributive property, we will distribute the x, and then given that we have a quadratic equation, we will subtract 10 and now use our factoring techniques. I will factor x squared plus 3x minus 10 into x plus 5 times x minus 2. Using the zero product rule, or setting each factor equal to 0 and solve for x. X equals negative 5 and x equals positive 2. Once again, let's make sure we are checking our solutions, the value of x into the original equation. When I take a negative 5 and replace it in for x, we notice right on the very first logarithm that we get a log of a negative number. So this means a logarithm of any negative number, whether it meets the first, both, or one or the other, is telling us that we do not have a solution. So x equals negative 5 is an extraneous solution. When we replace x equals 2 into the original equation, we notice that we get the logarithm base 4 of 2 plus the logarithm of base 4 of 2 plus 3, and that's going to equal the logarithm base 4 of 10. Again, our logarithms both positive, therefore x is equal to is a solution. I hope you found this video helpful.